Hello and welcome to another math video. We're talking about the surface area of spheres and hemispheres. Now, we don't have time to prove it right now, but the surface area of a sphere, which is just like a ball or a 3D circle, the surface area of a sphere, believe it or not, is 4 pi r squared. So this top portion, which I'm going to shade in purple, is 2 pi r squared, and the bottom portion, which I'm going to shade in blue, is also 2 pi r squared. And so when you add those two surfaces together, the top hemisphere and the bottom hemisphere, you end up getting 4 pi r squared. Now what happens is when we have a hemisphere, if we chop this ball in half, we remove the purple section or the blue section, whatever we want to think about it. But we're going to remove the blue section, the purple section. So we still have 2 pi r squared on the bottom. But what we've done by kind of chopping it in half is we're presenting a new surface to everybody. We're presenting this new surface. And what is the shape of the surface that we're presenting? Well, it's a circle. And that new surface that we're presenting has an area of pi r squared. So if the bottom blue is 2 pi r squared and the flat middle circle is pi r squared, 2 pi r squared plus pi r squared is going to be 3 pi r squared. So it's not very intuitive, but I suppose when you think about it, it makes sense. A full sphere is 4 pi r squared, and a hemisphere with that cut section, that kind of cross section showing, is 3 pi r squared. So let's do an example of this. What we want to know is, first of all, is this a sphere or a hemisphere? Well, it's definitely not a hemisphere. It's a full sphere. So the surface area is 4 pi r squared. Do we know what 4 is? Yes. Do we know what pi is? Yes. Do we know what r is? No, we don't know what r is. They're not giving us the radius. They're giving us the diameter. We want to know what the radius is. So in this case, the radius is half the diameter, so 15 centimeters. Now that we know what the radius is, we can continue on. 4 pi r squared. So when I chug all of this into my calculator, 4 pi 15 squared, I end up getting 2,827.43388 blah 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 centimeters squared. So if I want to round this to the nearest hundredth, this is my hundredth. So 2,827.43 centimeters squared. Perfect. We'll try another one here. This is not a full sphere. This is a hemisphere with that cross section showing. So the surface area is 3 pi r squared. And do we have the radius? Yes, we're given the radius is 3 feet. So this is pretty simple. 3 pi r squared. So 3 times 9 is 27. 27 times pi is 84.82300 blah 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 feet squared. So the surface area of this object is 84, if we want to round it to the nearest hundredth, 0.82 feet squared. The last example we're going to do is the surface area of a lacrosse ball is approximately 129 square centimeters. what is the diameter of the lacrosse ball? So if you could just permit me to draw a really, really terrible picture here, I'm going to try and draw a lacrosse ball. Perfect. I don't know about perfect, but whatever. So we can find the radius of this lacrosse ball. They want the diameter, but let's find the radius first. If the surface area, this is a full sphere, so it's 4 pi r squared. The surface area is 129 square centimeters times 4 pi r squared. If I want to get r by itself, I'm going to divide by 4 pi. So r squared is 129 divided by 4 pi. And if I want to get r, I will square root this side and square root that side. So it's the square root of 129 over 4 pi. So I'll put that into my calculator. 129 divided by 4 pi. And the radius I end up getting is 3.20398, blah, 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 blah. Centimeters as a unit. So if I take this value, I know I'm carrying enough. We want to the nearest tenth, but I'm carrying enough digits. So the diameter is twice the radius, not pi. So twice 3.20398 centimeters. So I'll take that previous answer, multiply it by 2. I'm going to get 6.4 centimeters. Perfect. So the diameter of this lacrosse ball is 6.4 centimeters. That is all the way from one side to the other, 6.4 centimeters. Thanks.